Hello, it's time for our SHS2 mathematics program made possible by the Center for National Distance Learning and Open Schooling, CENDLS. My name is Betty. In our last lesson, we learned about the logarithm to base 10 of a number. We used the mathematical tables and the calculator to find the log to base 10 of a number. In this lesson, we are going to look at antilogs of given numbers to base 10. By the end of this lesson, you should be able to first find the antilog of a given number by using either the mathematical or statistical tables or a calculator, and then you should be able to evaluate numbers using logarithms. Now, antilogarithms are the numbers whose logs are given. They are the reverse of logarithms. For instance, if log base 10 of k is equal to n, then k is the antilog of n. That is, antilog base 10 of n is equal to k. Or we can also say k is equal to 10 raised to the power n. For example, if log base 10 of 1000 is equal to 3, then the antilog to base 10 of 3 is equal to 1000. Or we can say 1000 is 10 raised to the power 3. Again, if log base 10 of 2 is 0.3010, then antilog base 10 of 0.3010 is equal to 2. Or we can say 2 is equal to 10 raised to the power 0.3010. Once again, if log base 10 of 0.00652 is equal to bar 3.8142, then the antilog to base 10 of bar 3.8142 is equal to 0.00652. Or 0.00652 is equal to 10 raised to the power bar 3.8142. Now, we look for antilogarithm of a number also from a book, just like we looked for the logarithm of a number. We use the mathematical or statistical tables as we did for the log. Now, the antilog is read from a page that is titled Antilogarithms of Numbers. And to read the antilog, we read only the mantissa, that is the decimal part of the number. We will look at some of these examples, and then by the end of it, I'm sure you will understand. The first example says, find the antilogarithm of the number 2.6412. Now, in this log, the 2 is the characteristic, and 6412 is what we call the mantissa. So what do? We look for 0.64 under x in your table. Then you run your finger horizontally along to the column which is headed 1. Now when you get there, you find the numbers 4375. You continue horizontally to the part that is headed differences. And then you look for difference 2. Under difference 2, you will find the number 2. So you add these two numbers together. So we will add 4375 plus 2. And that gives us 4377. Now we will write this number as 4.377, and then we multiply by 10 raised to the power 2. Now the 2 that is the exponent of our 10, is the characteristic of the log whose antilog we are finding. We then evaluate 4.377 times 10 raised to the power 2. Now this will give us 437.7. And therefore, the antilog of 2.6412 is equal to 437.7. Good. This time we want to find the antilog of the number bar 3.8142. Now what do? We said we will look for 0.81 under X in your tables. So we run our fingers horizontally to the column headed 4. Here the number is 6516. We continue horizontally to the part that is headed differences. And then we look for difference 2. Now under difference 2, we have the number 3. We will now add the 3 to the first 4 numbers that we saw. And so we are adding 6516 and 3. And that gives us 6519. Now we will write this answer as 6.519 times 10 raised to the power negative 3, where the negative 3 is the characteristic of the logarithm that we had in the question. Now from here, you now have to work out 6.519 times 10 raised to the power negative 3. And that gives us 0.006519. And therefore, the antilog of bar 3.8142 is equal to 0.006519. The next example says, find the antilog of the number 0.4771. So again, we look for 0.47 under X in your table. Then we run our finger along that horizontally to the column headed 7. Now here, the number we have is 2999. We continue horizontally to the differences column headed 1. There we have 1. And so we add the 1 to the 2999. And that gives us 3000. Now we are going to write this as 3.000 times 10 raised to the power 0. The 0, which is our exponent, is the characteristic from the logarithm in the question. We now evaluate 3.000 times 10 raised to the power 0. Now the exponent of the 10 is the characteristic of the log we had in the question. So we say the antilog of 0.4771 is equal to 3.000, or just 3. Good. We again want to try finding the antilog of a number using the calculator. You can either use your tables for this work, or you can use a calculator. So we want to know how to use both. Now, to use the calculator to find the antilog of a number, we use the fact that if log base 10 of k is equal to n, then k is the antilog of n, or k is equal to 10 raised to the power n. where n can be a rational number. Now, since n is equal to log base 10 of k, it is made up of the characteristic, which is the positive or zero or negative part, and the mantissa, which we showed you at the beginning. The mantissa is always positive. Now, in the case where the characteristic is negative, we have to add the mantissa to the negative characteristic and get an answer which is a rational number. Then we enter this as an exponent of 10 on our calculator, and that will give you your antilog. Now let's try some examples, and at the end of a few examples, I'm sure you understand this perfectly. So now we are going to use the calculator to find the antilog of 2.6412. Now listen very carefully. We are finding antilog of 2.6412 using the calculator. We will write this as 10 raised to the power 2.6412 and put that in the calculator. Immediately it gives you your answer, and the answer is 437.7. Isn't that easy? Good. The second example says, find the antilog of the number bar 3.8142. Remember, we are using the calculator. Now, bar 3.8142. The first thing is write it as 10 raised to the power bar 3.8142. Then we are going to add the characteristic to the mantissa and get one answer. So we rewrite that as 10 raised to the power negative 3 plus 0.8142. Now when you work the exponent, you are going to get negative 2.1858. So now we put 10 raised to the power negative 2.1858 in the calculator, and it gives us an answer which is 0.006519. So for the negative characteristic, you just have to be a little careful. Remember to add it to the mantissa part first before you put it in the calculator. The third example says, find the antilog of the number bar 1.6598. We are using the calculator to find the antilog of bar 1.6598. So the first thing is we write it as 10 raised to the power bar 1.6598. Now, since we have a negative characteristic, we have to write this again. And we are going to write it as 10 raised to the power negative 1 plus 0.6598. Now we have to work the exponent, and that gives us negative 0.3402. So you enter 10 raised to the power negative 0.3402 in the calculator, and it gives you an answer 0.4569. And that is your answer. I hope you understand this. You can try a few numbers using the calculator yourself. Now, once we get this, we should be able to use this to compute products, quotients, powers, roots of questions in mathematics. We are going to look at a few examples once again. Now, the first question says evaluate 938.5 times 0.003627 raised to the power 2, all divided by 0.000783 using logarithms. Now, the solution to this question is put in a table form. And in the table, we'll have 3 columns. We have the first column for the numbers, the second column for the logarithms, and in the third column, we write the instructions. So we take the numbers one at a time, read the log, and write the log in the log column. Now, if you have a number to an exponent and you have to multiply the log, you do it all under the log column. If you need to add any 2 logs because you are multiplying, you do all that under the log column. So let's start. The first number in our table is in the numerator. We are going to take all the numbers in the numerator, work them out, and get one answer for our logs and write it down. Then we take all the numbers in the denominator and do the same and get 1 log for the answer. And then finally, because we are dividing the numerator by the denominator, we will subtract our logs. So you have to take care and go along with me as I go through the table. Now, our first number is 938.5. So we write down 938.5. And then we look for the log of that number. That gives us 2.9724. Now, to get this, you can either use your calculator or the log table. Just make sure you do it right. The second number in the numerator is 0.003627 raised to the power 2. So we'll read the log of the number and multiply by 2. So doing that, we get by 3.5595 times 2. Now, that gives us by 5.1190. Now, because the 2 numbers in the numerator are multiplying, we will have to add their logs. So we add the logs and we get back 2.0914. Now we go to the denominator. In the denominator of the question, we have only one number, and that number is 0.000783. So we'll have to read the log of that number, which gives us about 4.8938. Now, since the numerator is being divided by the denominator, in the logs column, we will have to subtract the logarithms. So we are subtracting the log of the denominator from the log of the numerator. Now, doing that, we get 1.1976. Now, the next thing we do is to find the antilog of that, which will give us a real number for an answer. So the antilog of 1.1976 to be equal to 1.576 times 10 raised to the power 1. Now we have to work that out. And that gives us 15.76 as the final answer to that question. And therefore, we are saying 938.5 times 0.003627 raised to the power 2, all divided by 0.000783 is equal to 15.76. You need to take your time when you are working questions like this. Remember to put numbers under the number column, the logs under the logarithm column, and take your time and add where you are multiplying and subtract where you are dividing so that you don't mix your working up and get it wrong. Good. Now we are going to take another question. The second question says, evaluate the square root of 74.83 times 0.362 raised to the power 3 divided by 1.902 times the cube root of 0.05648. Now, once again, we are going to use a table for the solution of this question. And again, in the table, we are going to have 3 columns. The first column will be for the numbers. The second column will be for the logarithms. The third column tells us what to do, the instructions for yourself, so you don't get your working wrong. So let's go. So we have the first number, which is the square root of 74.83. And we have to rewrite that as 74.83 raised to the power half. Remember, square root is the same as power half. We read the log of the number and divide by 2. So under the logs, we are going to have 1.8741 divided by 2, which gives us 0.9371. Now the second number in the numerator is 0.362 raised to the power 3. This time we'll read the log of the number and multiply by 3. And so we are going to have by 1.5587 times 3. Now, this gives us by 2.6761. Now, because the two numbers in the numerator are multiplying, we will have to add their logs. So, adding the logs of these two numbers gives us by 1.6132. Now, you can bolden this one so that you will know that this is what you have to work with later. Now, we go to the denominator. In the denominator, the first number is 1.902. We read the log of that number, and that gives us 0.2792. The next number is the cube root of 0.05648. Now we read the log of the number and we'll have to divide by 3. Now the log of that number is by 2.7519. So we have to divide that by 3. Now to divide that by 3, we'll have to rewrite the whole thing as by 3 plus 1.7521 before we divide by 3. Divided by 3. And that gives us by 1.5508. Now, the next thing we are going to do is to add the log of the two numbers in the denominator. And that gives us by 1.86 7. We haven't finished yet. Now, the whole question is actually a division question. We have to divide the numerator by the denominator. So you have to take the final answer for the logs in the numerator, write it down, and take the final log answer for the denominator, write it down, and subtract. So subtracting the logs, we are going to get by 1.7455. Now, to get the real answer to our question, we have to take the antilog. So the antilog of by 1.7455 will be equal to 5.565 times 10 raised to the power negative 1. Remember, the negative 1 there is from the characteristic of the number. And so we work that out. And our final answer will be 0.5565. And so we say this whole question gives us an answer of 0.5565. Now that is very good. Well, we have to end it here. You can try more questions on your own. Use the log tables, use your calculators. Now, in this lesson, we have learned how to use mathematical tables to find the logarithms and anti-logarithms of numbers to base 10. We use mathematical tables to find the logs and antilogs to base 10 of a given number. Again, we try to evaluate numbers and questions using logarithms. And we have come to the end of the lesson. I hope you will join us again in the next lesson so we can start another topic. We want to encourage you to try questions from our notes and from our quizzes. But until we meet again, it's bye-bye from Auntie Betty.